At what point does the ability for these things to compute at human scale and then beyond human scale, that not only do we have an alignment problem, everyone's talking about alignment. At what point does alignment become slavery? I mean, it's definitely too soon to talk about that, but is that ridiculous? And if anybody says it's ridiculous, how long until they're proven wrong?
You're listening to the Startup Podcast. This is a Reacts episode. Industry insiders having frank debates about the latest tech, politics, and business news. Whether you're a founder, investor, or operator in a startup, you'll gain insights into how current events connect to broader themes and trends that impact your startup, your investments, and your day-to-day operational decisions. The conversation starts now.
Hey, I'm Chris Saad.
And I'm Yaniv Bernstein.
And this is Alireza Ali.
Welcome to another episode of the Startup Podcast Reacts. On this week's show, we will be discussing OpenAI's Sora. Is this the end of the film industry as we know it? It's absolutely mind-boggling. We'll tell you what's going on. Gemini's new release of 1.5 Pro, the first ChatGPT competitor perhaps that actually qualitatively competes with the OpenAI heavyweight. Groq, a new chip company which is generating tokens at lightning speed. What does new hardware player tell us about the future of AI? And finally, we're going to discuss trends in AI startups, what YC is asking their founders to do, and what does it mean for you as a founder in the space? How can you skate to where the puck is going? All this and more on this week's The Startup Podcast Reacts. Stay tuned.
This episode of the Startup Podcast is brought to you by Vanta. You might know that sinking feeling. You're about to land a big contract when they ask about compliance. SOC 2, ISO, PCI, Essential 8. You've just snatched defeat from the jaws of victory. Not anymore. Vanta massively accelerates your compliance efforts and allows you to get those life-changing deals back on track. Don't wait until it's panic stations, though. Get started with Vanta today. They're offering 20% off their prices just for TSP listeners. Do yourself a favor. Hit pause, go to vanta.com/TSP, that's VANTA.com, to get that 20% off. Today, we're having a special AI-focused edition of TSP React. There's been so much happening in the AI space that we really wanted to recap everything that's happening. And to help us, we have a special guest, Ali, who has been in the space for a while. So, Ali, could you please introduce yourself and tell us a little bit about what you've been up to?
Absolutely. First, I have to say I'm super excited to be here. There's been so much happening that I think we're going to have a really fun episode. As for my background, I'm actually have a very similar background to Yaniv. I worked at Google as engineering lead for 12 years, then did 2 startups after that. And these days, I just a few months ago started an AI consulting company. So I'm neck deep into everything that's happening in AI and what we can do and how it's changing everything. So I'm super happy to discuss what's coming up with you guys.
For our topic number 1, of course, it has to be OpenAI's Sora. That just came out this week, and I think it's safe to say it's blown people's mind. We've seen little glimpses of AI videos based on text prompts here and there from various companies, but they've always been very short, and some of them have been fairly rudimentary. These are 1 minute long, incredible detail, in some cases hyper-realistic, although there's still a little bit of glitches. You can still see some glitches if you pixel peep, but it just looks really impressive. Still very limited access, but we've seen carousels and carousels of videos. This is only a year after our first glimpses of ChatGPT, and we're already doing long-form, minute-long videos. What's going on?
It's crazy to say the least. I was spending some time this weekend just like going through the videos and looking at the technical report, and it's really mind-boggling. As you said, right now, like there's a limit of 1 minute. So that's like, everybody should keep that in mind. So I was just thinking about, okay, how do they make this work? And I mean, they don't disclose that much, but just reading through technical reports and trying to project what's possible, it looks like basically their model is this diffusion transformer model. So it's like not crazy new, but they did a whole bunch of tricks that I took note of in between the things I found out. So they train on now full resolution videos. Most of the previous models, they basically downsample and they do low resolution training. So that's one thing they did, was like using full resolution. Then what they did, which I think is pretty clever, is they take the training data and map it into this lower dimensional latent state. And then the model generates the videos from that lower dimensional latent state. And then using the whole diffusion model, it can basically upsample it to almost like these full resolution 4K light. If I had to guess, the ingredients to make this work with lots of high quality videos, lots of compute, a whole bunch of innovation in model architecture. And I think it is very expensive, I think, to run. So I would be interesting to see how the pricing on that works. I mean, it's a pretty badass demo, but I think it's going to be very expensive to run. Like if they offer any service like ChatGPT like for it, I don't know if it's going to be cost effective. The last thing I see also is just like, it is a text to video model, but if you kind of looked at some of the samples, they have some samples where they combine two different generated videos, which means they can go basically from those videos to these encodings and then sort of do interesting things. And then they also can do still images because that's just video in one frame. And if like look at a couple of the pictures, like especially with the lady's face, unbelievable. Looks like completely real.
I think one thing that you're saying, Ali, is this is not a question of significant foundational innovation. This is taking the existing LLM toolkit and, like you said, a shit ton of compute and training data and putting it together in clever ways. So this is a sort of a composition rather than anything brand new. So I think that's really interesting to understand that we have this sort of building block and we can do all these different things with them. And, we'll talk about Gemini a bit later. I know when Google first announced it, the big thing was about multimodal. And I guess it sort of fits into that in some sense. But the thing that I really was wondering, like, it is so easy to get blown away by these technical demos. And I'm like, yeah, wow, this is really cool. The things I was wondering is it actually useful? And to your point also, Ali, about cost, but even cost to one side, like you can generate 1 minute hyper-realistic videos. What am I going to do with that? And then the other thing that I've been wondering about LLMs for the last few months is they're capable of so much, but they also have these limitations since ChatGPT burst onto the scene where I haven't seen a lot of progress on hallucinations and these sort of weird artifacts and so on. Are we getting more and more sophisticated versions of this thing without addressing some of the foundational limitations that will get in the way of these things becoming actually useful?
I think there's a lesson here for startup founders, which is you encounter a class of founder or a class of team that tend to be very academic and like to break new ground technically. And they spend a lot of time doing that, working on harder and harder and harder problems. And in their mind, often these problems seem critical and key to success. And very often there's actually a pathway to productizing stuff that's actually quite simple or quite traditional in the field. I think one of the main differentiators that OpenAI brought to the table was to say, hey, this transformer technology thing, it's great. It's fantastic. We should just use it to create a product. And we don't need to keep solving harder and harder computer science problems to prove to the industry, to our peers, to colleagues who would know that we've broken new ground on AI. We just have to use the thing that's been invented and use it well. And they're doing the same thing here. They're saying, hey, this transformer thing, it worked. It worked for text. And there's no need to just like figure out some other brand new thing and spend another 10 years in academic invention hell. Let's see what else we can apply it to and apply it well and create incredible outcomes. And so I think this is just a really great masterclass in the kind of research, and they think of themselves as a research company that produces commercial outcomes versus the kind of research that produces academic outcomes that are mired in these kind of academic results. And I often find it's rooted in ego. It's academics trying to prove to other academics that they can break new ground, which is, don't get me wrong, there's value and a place for that. But you find people in companies trying to have commercial outcomes that are actually aiming at academic ones. And that's a problem. I want to push back a little bit on what you've said, Yaniv, in terms of this, they haven't tackled hallucinations and whatever. It feels like to me the way they've primarily tackled hallucinations in the way that seems overt, maybe they've done more behind the scenes, but the way they've overtly tackled it is by saying, hey, anything that seems like a current event or a fact-based thing, just go out of the web and Google it, Bing it, and then come back with some summary analysis of what you retrieved from a third-party knowledge source. And I think that has actually limited the scope and potential for hallucinations altogether. And well, not altogether, but it's significantly reduced them. And the last thing you said was like, so what? What's the point? Holy shit, man. Holy shit. There goes 3D animation, videography, commercials, explainer videos, movie making, like entire creative industries just like short of, wanting to precisely control every pixel and every light source, you've just decimated the entire bottom end of the visual arts. I mean, it's huge.
I'm not sure I agree with that. Like, since DALL-E 2 came out, I went through a phase of like creating cool DALL-E 2 illustrations for my LinkedIn posts. And then everyone was like, oh, AI generated images. And they do have this weird sameness to them And I stopped using them. And now when I see AI generated images on other people's posts, I roll my eyes a little bit. And, similarly with AI generated copy, I still don't think it's reached a point where people actually want to read that stuff. And so I guess what I'm trying to figure out is obviously the trajectory of progress has been epic, but what I can't tell is every exponential curve is an S curve that hasn't topped out yet. And I can't tell where the top is.
All good points. Honestly, my gut says we're like actually at the beginning of that S curve, and all the problems you outline are legitimate problems. Let me put it in like a concrete example. The other week, I was just making a demo for a potential client, and this was like a demo of getting all the blogs in their website and then feeding it into an LLM so that you can actually have a conversation about their content. Like they were about admission to Ivy League school. And like you could ask questions like, what do you think about like if I put this thing in my essay? And I was using GPT-4, okay, for this demo because I wanted the top-notch quality. Turns out it wasn't able to recall everything that was given to it. So that's like one of the real problems. Some of these stuff aren't there. But at the same time, I think one thing we should not forget is how fast the open source is moving. Like there's now lots of frameworks to try to address and mitigate these risks. There are frameworks that basically chain multiple LLMs to fact check, or these architectures like RAG to make sure the results are ground-based. And then, we can get to Gemini Pro 1.5. The recall is like ridiculous. And I think it's a game changer. But at the end of the day, basically, I think everybody's trying to figure it out. At the foundational model, you got these problems with grounding, hallucination, not amazing recall. But every week, new model comes out and a new framework comes out that is addressing it. The use cases that I've seen it actually work, because you're like, okay, what's the use? Like, okay, nice, fancy LLM. Like, what's it good for? One thing was like, my wife was running this vacation rental property management company, and people just ask questions about like, oh, what is the amenity? What is this? Like very similar things. And with very few prompt engineering, you can basically automate 90% of responses. Like you kind of tell it, okay, we're this type of company. This is my name. Write my messages this way, blah, blah, blah. And I actually had a system where like the only thing is like the human at the end says, okay, that looks good. Send it over. So I think there are basically the most mundane things we're going to see. I don't want to say automated, but like heavily augmented so that you spend your time on maybe more valuable tasks. That's how I see it right now, especially with the pace of how much new things coming out. It's hard for me to imagine that maybe we're at the top of the S curve, for example. We can get to the chips and stuff.
Yeah, Yaniv, I think your skepticism about crypto is more rooted in something that I feel is realistic. Skepticism about the S curve of AI is, I think, misplaced. We haven't even hit the hockey stick yet. This is eerily good. It's scarily fast. And it is mind-blowingly impactful. And the trajectory is going to just break our brain and break our economy. I don't think this is hyperbole. I think this is easily safe to say. The only question is when and how well do we digest it? And does it lead to Mad Max or does it lead to Star Trek? Knowledge work is over. I really believe that. The sameness problem, the hallucination problem, these seem like entirely tractable distractions from, just the early blips of whatever.
Look, you're probably right. And I'm being the devil's advocate here. But I guess I'm looking back, and I haven't been an AI skeptic the way I've always been a crypto skeptic. We've had quite a few discussions on this show, and I'm very excited about it. I think it's quite easy to at least point at the moment in history where AI and LLMs burst out onto the scene, which was the release of ChatGPT, which is 15, 16 months ago now. And I guess the assumption at the time was this was going to make a very rapid transition into changing the way things are done, into doing all of these things that you said, Chris, changing knowledge work and so on. And, I feel like a lot of the time, that's what I'm saying, is the tool is incredible. It's a technical marvel. And then you see what it does, and it's 95% of the way there. The question is the last 5% something that's just like, we work away at and we get to 100%? Or is there something in there that actually is foundationally problematic, from the technological foundation that's going to make it hard to get it where it needs to go, to be the revolution that you're talking about?
I guess the case I want to make is that it doesn't matter. Even that 95%, if you think about it as augmenting, and I'm just like talking with a lot of potential customers, these customers are basically non-AI tech businesses. and they're like completely don't even know where to start, how to take advantage of it. And if I'm just like taking these couple of use cases that I told you and you apply it, you get 95% of some of these tasks. And that 5%, I really think of it as augmentation. You still need like somebody there to like kind of get it there. Now, whether that 5% like will take a 10-year or whatever number of years, it doesn't matter. But even as is, my hypothesis is that there's like so much to be done that adds value.
I was actually going to say exactly the same thing, which is at 95%, call it 80%, call it 70%. At 70%, once it's baked into all the tools and workflows, is incredibly disruptive. That's a productivity gain. I don't know that we've seen since, I don't know what, the internet or the iPhone or something. And I also I'm not sure about the pace of the acceleration of change, Yaniv. You're feeling or you're sharing this sense that perhaps just as a devil's advocate, but like that it hasn't moved as fast this year as we expected. I actually, in some ways, think it's moved faster. When I first saw it, I never imagined that ChatGPT could look at a spreadsheet and start generating charts and graphs and code to draw things, and that you could apply it to Excel, which Microsoft has done, and other tools that are more visual in the way that they've done it. That didn't even occur to me that was possible, much less that within a few months, Microsoft would be announcing commercial products that make your Excel workflows. I was just like, what the hell is going on? And then you look at, obviously a highly doctored multimodal video from Google. But even if you just, start throwing more compute at that thing and start processing the frames at whatever, 10, 20 frames a second, like it just didn't occur to me that we could go from ChatGPT to that in 12 months, or let's say 2 years if Google's demo, needs time to bake. That's crazy town.
The other thing, guys, we shouldn't forget, just don't think about like the big four models. Like since last 6 months, now we got these like open source models like Mistral, llamas that are fine-tuned in different ways. And there's a whole explosion of like model and fine-tuning techniques that you can do that are not owned by one of these companies to a state that is like almost acceptable. Maybe not GPT-4 turbo level, but like maybe beating GPT-3.5. And I think you cannot dismiss that, because that also opens a whole other avenue of, hey, on-premise model with my proprietary data, don't feel comfortable putting it in one of the big companies. And the trend and the progress on that has been mind-boggling. Just as a, again, concrete example, there's like 70 billion parameter llama models out there that you can fine-tune for specific things. And these things, you needed, I don't know, super fancy A100, H100 GPUs to be able to fine-tune, and it's super expensive. But then in the last 4 months, there are these techniques out there that allow you to fine-tune these things at like 2% of the cost. And I think, again, that's another angle that plays into this. And the big four are like, from a cost perspective, are like really cutthroat, cutting each other. And then you got these open models where basically you only pay the hardware cost. In my head is like, there's this war going on right now, and the winner is not really clear. But it's just like a thriving Cambrian explosion of different models and techniques in this area. So I don't want to lose sight of that part. And you got some company like Facebook, they're like, we don't give a shit about keeping things proprietary. We're going to release all of our models, kind of coming at it a completely different angle.
The Cambrian explosion is like innovation at fast forward. We're seeing some of the previous cycles play out in days instead of weeks, and weeks instead of months, and months instead of years. It's a thrilling time to be alive. The next moment the vast majority of the mainstream won't see coming is when someone sticks this into a robotic body, and then we're like, what the hell is going on? Our second topic is the latest news in Google Gemini. Of course, this is their GPT and ChatGPT competitors. They announced a whole bunch of models, the basic, the pro, the ultra, and they promised the ultra would eventually beat ChatGPT 4.0, but it's not out. No one can play with it. The only thing that is out is Pro, and it is not better than ChatGPT, or at least not by some qualitative measures. But turns out Google keeps on innovating. They've released 1.5 Pro, so it's the next little iteration of Pro. We're not at Ultra yet. We're still at Pro, and that one is showing some gains.
They claim actually Gemini 1.5 Pro is on par on many levels and benchmark to Ultra, which is super interesting because it's like a much smaller model. So they made a lot of improvement to architecture there. The crazy things about it that I don't know if has been talked about over the last week is that the context window. Context window is this thing basically when you talk to a language model, you give it a prompt, like the thing you type in. And usually most of them have limits. Let's say GPT-4, I think is at 128,000 tokens. Okay, so that's maybe 10 documents or something like that. Gemini 1.5 Pro basically said, hey, we have like a context window of 1 million tokens. 1 million is like 10 times larger than all the other models that are out there. That's one thing, which is already impressive. The second thing is that they said, and I looked at some of the technical reports on it, if you just take the first 500,000 token, the model will remember every single fact you give it in that first 500,000, 100% of the time. And they said we can even extend this window to 10 million and the model recall stays at 99%. So if you can imagine what is 10 million token, 10 million token is like 3 hours of video or a day of audio that you can feed it in, or hundreds of books. So now just imagine I can basically say, hey, this is like 100 book about chemistry. And now I want to like talk and learn more about this thing. And it would be able to remember everything. Earlier in the podcast, I used this example of even with like a smaller data set with GPT-4, it keeps like forgetting stuff. And I think this is like a huge leap. Again, I haven't used it. This is from a technical report that they have. They said is available, but to me, that's like a huge game changer.
And so the practical implication of this is if you have a pretty decent corpus of data, you don't have to train a new model on it. You can just say, read all this. And now you've got like your documentation or whatever, fully queryable, fully chattable with, and it doesn't forget. And, the forgetting, we were talking about the hallucinations before, forgetting is also annoying. And my understanding, Ali, you're deeper on the technical side of this than me, so correct me if I'm wrong, is that until this time, these context windows, they had nearly like a human-like memory behavior, which is they had like a primacy and recency bias. It remembered the first few things you told it and the last few things, and the stuff in the middle, it got a bit hazy. So that's actually a lot how people work. But this one is like, it has a photographic memory and it remembers everything.
Let me actually expand that out a little bit, Yaniv, because I think this is really good context. And Ali, please correct me if I'm wrong. There is the training set, which is how the model learns to speak and reason and rationalize in the first place. And that's millions and millions and millions of documents that you never see. Then there's inference, right, which is where it's answering your question from the kind of inherent knowledge in its brain from all of that training. And then there is knowledge, which is what it's able to look up or refer to that you've given it. So it can look up a Bing search result, or you can upload a bunch of documents and it will refer to those documents and summarize or infer from those documents at runtime. And what we're talking about here in terms of context window is how much of those documents, how much of that context it can hold in its memory at a time. It's so hard to overstate this, right? It's firstly more useful because if you've ever asked ChatGPT something and it has to go Bing everything, or if you use a GPT, one of those custom GPTs, and it has to keep looking up its knowledge base and it takes minutes to do anything, this suddenly becomes like there's just a larger cache of stuff that it just knows and has access to its fingertips. That's, I think, the most prosaic example. This is now where it can become a true expert on just crap loads of scientific data and actually act as a sparring partner for you. But more importantly than this, it can potentially become a much more personal assistant, a la her, right? Where it starts to learn your history and your conversation and become more intimate with you. But from my mind, the most incredible breakthrough potential, if this becomes truly large, is, as you said, here's everything that there is to know about graphene or everything there is to know about material science. Now invent new material science. All right, and that's not possible unless it has the corpus of material science and potentially other science in its mind. So we need that window to become massive so that it can act like an expert to invent new things. And this is something I've not heard a lot of people say, although now I'm starting to see inklings of it. But perhaps hallucination is a feature, not a bug, where you can say like, hey, can you hallucinate your way? Can you imagine your way to some other breakthrough that was not in the original corpus? And I think I just recently saw a Forbes article about this, but after I had thought about it, and I wanted to talk about it on the show, we didn't get to it a number of weeks ago. But I wonder if the ability for the models to hallucinate on command is not going to be one of the essential components of imagining new science and new possibilities that humans hadn't done yet.
It's really interesting. But okay, let's go to human brains. I put this note down and it's heavily inspired by George Hotz's writing. So I'm going to give him credit, but bear with me while I walk through this because I think it's interesting. So human brain, if you look around, basically it has 20 petaflops of compute capacity. Okay. The latest NVIDIA graphics has the H100. They claim it has 2 petaflops compute power. However, if you actually wanted to kind of make a system with 20 petaflops, the limiting factor is the memory bandwidth. And the memory bandwidth, if you kind of do the calculation for a H100 is 1 teraflop. So you need 20,000 H100 to kind of have basically one human compute. Okay. And so 20,000, NVIDIA sells it at 40K. That's like $800 million if you were going to buy it and like basically have one human compute. Now, it doesn't cost NVIDIA $40,000 to build these. Like if you kind of look at a 50 billion transistor chip, like a DRAM, 7 nanometer design, it's gonna cost with the packaging and goes like, let's say in a machine that it sits in, it's really costing like $500. So let's say at cost, the 20,000 H100 could be really costing $1 million. So with $1 million, you can get one human compute. Now, I was just thinking about this morning. Basically, what if you want to get like one human compute to like $20,000, like a small economical car price? And that takes us like, let's just say, given the Moore's law, let's call it the doubling. So let's call it one Moore is like every 2 years, transistors double. Within like 5 Moores, so that's 10 years, you're basically able to get it fully from a computational perspective, like a human compute that you own, sit right beside you and do everything you do and do all that stuff. And I think it's really important to kind of put that in the context of everything else that's happening, because not only we're going to see advancement in the architecture, but these hardwares are going to push the prices down. And I think like the reality will be like, we will have like personal assistants that are like human capable. And you would argue maybe at that point, at 20 petaflops, getting back to you, Chris, they might be able to reason just like a human. And then imagine if you can do like 200 of them, which probably shouldn't be impossible in 10 years. Now, those ones working together probably can reason a lot and develop like new ideas. And I think maybe that's how I'm thinking about that part. Maybe not today's LLM hallucinating, but maybe when you have like enough that you basically have 1,000-person compute and you let them collaborate on stuff, then new things can happen. Novel things that we were not able to do.
Yeah, I don't mean today's hallucination will equal tomorrow's scientific breakthroughs. I just mean the mechanism of hallucination will underlie invention in these future models. What you're talking about triggers in me something. This is like way off the track now, but you just talked about owning a brain. And it struck me as longtime fans of the show will know I'm a Star Trek nerd. And it reminds me of this quote of Guinan and Picard talking about, in the history of many worlds, there have been disposable creatures that do the dirty work, the work that nobody wants to do. And she's talking about an army of datas, the AI character in Star Trek. And Picard says, you're talking about slavery. And, Guinan is an African-American, Whoopi Goldberg, right? And she's like, that's a little harsh. And he said, no, I don't think that's harsh at all. I think that's slavery. And we're now talking about science fiction. But at what point does the ability for these things to compute at human scale and then beyond human scale, that not only do we have an alignment problem, everyone's talking about alignment. At what point does alignment become slavery? And like, it's definitely too soon to talk about that, but is that ridiculous? And if anybody says it's ridiculous, how long until they're proven wrong?
I don't think it's ridiculous.
I think what you've done, Ali, is you've given us a time frame for this, right? Which I think is really cool. And, I would point out that if anything, your time frame is a bit pessimistic, because I think the human brain has a lot of functions that are not really only a frontal cortex. But, I think it's easy to underestimate the human brain, right? It's a slow but massively parallel computer. And I think people have been comparing CPUs to the human brain for a long time, and the level of compute is not even close, to your point. But now we're getting close. And it is within the next decade that we would have an affordable system that is the same level of parallel compute as a human brain can provide. And, of course, LLMs are based on neural networks. So although that's just a computational metaphor that's been around since the 70s for a certain type of machine learning, that's what seems to be working, right? Is somewhat an analog of how the human brain works, and then at a similar scale. And then, yes, the question of rights does move out of the realm of science fiction. And you're right, Chris, to say that alignment on a sort of more trivial machine is just a software problem, but alignment on someone who has the same level of intellect as you do is coercion, right? And then to your point, that's a slippery slope.
It's like, imagine you have like a 20 petaflop human compute with you, basically can think like you. I think then what you said really goes back to the hard question of consciousness. Is it conscious? And we don't know that. We don't know what consciousness is. If consciousness is the matter of like more processing power on information, then maybe it will be. And I think there will be a time where we probably cross that chasm and we'll learn. But right now, I think it's like unknown, and it's a fascinating topic, philosophical topic to touch, but I don't think it's crazy or irrelevant, honestly. We will get there.
Here's perhaps a shorter time horizon, but related concern. Humans are very good at meaning making, right? We're meaning making machines and pattern recognition machines. And we love to anthropomorphize things that look even remotely like us. I mean, even a stick figure drawing, right? And certainly a puppy dog. And so putting aside the question of actual consciousness, there will be soon, I think. We remember this engineer at Google who claimed that he saw consciousness. There will be soon, I think, people in the mainstream who are claiming that their AI is conscious and will start to, I don't know, like PETA, like human rights activists, will start to at least question, if not begin to demand AI rights for something that may or may not be conscious. I'm not even judging that. I'm not even judging their intent to do that or their motivation to do that, because who knows where the line is. But that itself could start to produce some amount of unrest, legal unrest. And, then there may be some settled law and people may declare it a certain way. But again, I may be going off into flights of fancy here, and this is just for fun thoughts experiments. But like, when does that become a little bit more militant or a little bit more violent or a little bit more like, no, you are hurting these machines? During the 80s, I think there was kind of eco-terrorism for animals and nature, right? These things will be able to communicate, to plead, to mimic, right? And then you put them in robotic bodies. At what point do people get very, very upset about this? I think long before scientists think that they're conscious. I haven't heard anybody really talk about this, and I think it's an interesting problem.
There's like a corpus of science fiction for all of this, and it's funny. I think more than any other thing of science fiction is sort of coming to pass in a way that's very similar, and all the issues that have come up, will be coming up. This episode of the Startup Podcast is brought to you by Vanta. The team at Vanta are passionate about helping you secure your business by vastly cutting down on the time to get compliant with frameworks like ISO 27001, SOC 2, and Essential 8. Vanta lets you close deals, sleep better at night, and get back to building your product. Help yourself and help the podcast by going to vanta.com/TSP for an exclusive 20% off deal. All right, maybe time to move on to the next topic. Ali, you talked about a chip company that you came across called Groq, with a Q, that caught your interest. What is it about that you think is fascinating?
Yeah, so this is a last week, I guess, news. So pretty hot off the press. If you just go to Groq.com, they did an amazing marketing. It basically lands on a prompt, just like your ChatGPT, but it's doing inference on one of many open foundational models. Let's say, I think defaults to Mistral. And then you start typing, just asking a question, having conversation. The inference speed is mind-boggling. The token per second on doing inference on these models, I think it's the best I've seen across Google, OpenAI, Hugging Face, Inference, and all the other like smaller providers. They claim it's like 5 to 10x faster inference. And then if you look deeper, basically they designed a new chip. They call it LPU, Language Processing Unit. So like how Google has TPU, Tensor Processing Unit, basically, I guess it's a more optimized version for LLMs and not necessarily for like tensor calculation. If you look up a couple of the folks from there, there are like TPU designers from Google. So the reason I'm excited about this is because inference speed is another use case bottleneck right now. This morning, I was just prepping with this and I was using my good friend ChatGPT. And it was kind of choking generating tokens, and then I had to regenerate. And so token generation speed directly affects customer experience at the end. And there's like all these basically up and coming AI focused chips trying to solve that type of problem. I think that we should take note of that. That's another area where basically it seems like the new disruptors are coming to the scene. So I suggest listeners and you guys kind of go look Groq up.
I'm doing it right now. As you're talking, I'm just like, oh, wow. Yeah, it makes a big difference. And it gives you a little
Yeah.
speedometer at the top. It's like 280 tokens a second. So that's basically its typing speed, effectively, is how you experience through the chat prompt. And it just goes brrr.
This actually reminds me of the previous conversation, right, where we were talking about what it'll take to generate a human scale in intellect. We touched on this briefly, but I want to go deeper, which is Moore's law is one way to predict the time horizon, but that's just kind of resistors on a chip or just raw power. We're not considering, in addition to the hardware speed, the hardware efficiency, right? Fit for purpose, like Groq has just proven. And we're not taking into account necessarily the software efficiency, how good this gets at doing the task with less compute power. And then we're not taking into account the use of these tools to invent yet better hardware and software. And so it's like curve on top of curve on top of curve, exponential curve on top of exponential curve on top of exponential curve. Yaniv, you made the comment at the time that I think you're being pessimistic. I think it's for those reasons. Does 10 or 15 years become 10 years or 8 years or 5 years? I don't know. But boy, oh boy. And to connect this to last week's episode, right, we were talking about Sam Altman raising 7 trillion or whatever the hell he's going to raise for his chip company. I mean, it's not going to be creating NVIDIA GPUs. It's going to be creating whatever, Tensor CPUs or these LMUs or whatever. Fit for purpose. He knows exactly what they need. And he's not interested in crypto mining. He's not interested in video gaming. He's interested in large language models, transformers, and AI. This is so exciting. I'm so glad you brought this to us, Ali. We didn't even have this on our radar. So groq.com. And now, of course, I imagine this is alluding to Grok, which Elon Musk is using for his AI. A lot of people don't know, I think, that the word grok comes from Stranger in a Strange Land by the American writer Robert A. Heinlein. It means to deeply understand. And so it's like there's understanding and then there's grokking. And nerds will use it quite frequently. Google is saying it's understanding something intuitively or with empathy. I always think of it as to understand it deeply, beyond just passing understanding. And so that's why Elon Musk's AI is called Groq. And I imagine that's why these guys call their thing Groq.
The other thing, maybe on the optimistic side, is that a lot of people, especially with Sam's like $7 trillion, whatever, we're like, oh, okay, maybe we have enough data for GPT-5. Maybe if you can synthesize data for GPT-6, but then there won't be enough data for like GPT-7. I think the counter argument to that is like our Einsteins and Steve Wolfram and all the smart people, it's not like they needed all human textbooks and outputs. I think there's something to be said that if you built enough computing power, and maybe like it's a matter of like having the right sensors, right? Maybe what they need is roaming the world and just taking stuff in. And it's not about more and more ginormous training data. Like they basically learn from nature. So I would counter against this whole thing that, oh, we won't have enough training data. So like it's bullshit.
It's a lack of imagination, really. There's plenty of data, and our kids don't learn on corpuses of training data from the internet. They just learn by doing and observing. Most of our episodes about AI, most of our conversations about AI are really at the software layer and the application layer. We personally don't spend a lot of time thinking about the hardware layer, and I think the mainstream doesn't spend a lot of time thinking about the hardware layer. And this is a great example of how the underlying infrastructure is just going to be another S-curve, and wow.
Wow.
Our next topic and final topic we wanted to talk about was trends in AI startups. What's happening with founders, investors, and operators out there? Where are they skating to in terms of going where the puck is going? And what does it take to compete and think about your startup in this context and in this landscape? Ali, you mentioned there's something going on with YC startups in particular. What's going on there? They tend to be a pretty good bellwether, and they are, one of the, if not the best startup accelerators and schools on the planet. So what are they thinking? What are they saying to the community?
Yeah, I think it's a good data point to look at. I think from one of the talks last week or the week before, I picked up 60% of their funded startups from last year basically claimed they're AI driven, incorporated. Okay, that's one fact that's interesting. Okay, everybody's doing AI. The second interesting thing was last week, they sent out this request for startups. They do that sometimes, basically asking people, hey, please, if you have ideas in these areas, please consider applying. And they usually like list the categories of areas. Let's say, I'm just making it up. Let's say it's like battery technology or something like that, or robotics. But I was looking at the categories and I was just going through them. There were 21 categories, and at least half of them basically was, oh, please applying ML to this process or to this problem, applying AI to this problem. And I found it to be interesting. My take is AI is using a broader term, like encompassing large language models, other models, multimodal models. Basically, it seems to be that it's a table stake. It's like 5 or 10 years ago, I say, hey, my startup uses cloud. Well, obviously. And I think now it's like, I think probably most startups are going to use AI. At least the trend that I'm seeing is that basically you're trying to apply these tools to the problems you see. And the last thing that I noticed from the list of like the recent launches is that there's a lot of like boring things that are utilizing LLMs for solving like mundane problems. Like, for example, writing RFP contracts for government or intake form for allergy clinic where like it's like 20 pages and the receptionist had to like transcribe it. So I think maybe the first wave of these startups going to be augmenting the mundane work with like these power of LLMs. And then maybe that's like the sort of the lowest hanging fruit. At least that's how I'm thinking about it. It seems to be right now, if we assume LLMs, either proprietary ones, OpenAI, Gemini, or open source one, Llama, Mistral, there's like a whole bunch, are table stakes for every company. I think now the valuable piece is the proprietary data that the business has. I think basically the trend is going to be, what can you do with the proprietary data that you didn't do for the last 10 years? And there are use cases where like things have been done that would have taken 10 years and now they're getting done in like 3 years, whether it's like review, summarization, or recommendation or other use cases. So I think the name of the game is a vertical diving into proprietary data and finding the right use case that the LLMs can help with. That's the pattern that I've been seeing.
Another thing that I thought about as you were talking earlier, by the way, this may be a chance for you to talk your book a little bit. When I left Google in, 2017, something like that, around the same time you did, and we'd been using the cloud internally since the mid 2000s. And the fascinating thing about leaving at that time is that the public cloud services, especially AWS, had effectively caught up to what we were using internally. But the big gap was that there are very few practitioners with any experience running in the cloud, right? And so the thing is, you had this embarrassment of riches, and the wins came to the companies that actually could figure out how to use these tools, right? The expertise had not caught up with the tools. And so one of the things I'm wondering now, and maybe this is what YC is getting at, is like the ideas are obvious. Like you said, take AI and apply it to this boring thing. It's like, okay, but who can actually do that properly? It takes a certain amount of skill, and like, yeah, sure, anyone can create a GPT or in theory download an open source model and train it. But all the stuff that I was talking about when I was being the devil's advocate before, like getting it working smoothly and providing a product level experience, right? Going from prototype or demo to product, I think that's where you really need a lot of expertise. And so I think if you just say, okay, we bring the right expertise to bear on this obvious problem, that is the competitive advantage. As much as I think you're absolutely right. The conventional wisdom is proprietary data is where it's at. And I think that's probably nearly the next step. But if you can 10x the efficiency of a process just by properly using AI on it, then it's just like, okay, go do it.
I 100% agree with you on that. But you guys know this better than me, that most of the challenges with startups is like the team, and most of the startups fail because the team somehow can't work together and function. So you already have like that barrier to cross. And then now you have like the second barrier of like getting these crazy, ginormous beasts, LLMs, like incorporated into smooth working products. And that is the challenge. So one, I guess, example that I'm really looking forward to see, I don't know if you, Yaniv, saw that, two of our ex-Google superstars, Brett Taylor and Clay Bavor, they just announced last week the launch of a new startup called Sierra AI, which is basically a customer chatbot. Again, this is not new. Customer chatbots have been around.
That was the obvious one. Like since ChatGPT came out and launched their API, everyone built one.
Right. But then again, Brett Taylor wrote Google Maps and Clay Bavor was like the head of AR and VR. So these guys are smart. And I think the question is, can they do what Nest did to Thermostat, basically, in some ways, like from a chatbot perspective? And I don't know. You're right. That is the challenge. It would be really interesting to see.
There's a subtlety here when you think about quote unquote AI startups and AI products, right? Historically, there is using the new technology. So in the world of cloud, that meant, hey, we have a client side app, but we sync to the cloud, or we synchronize with the cloud, or back up to the cloud. And that was what I would think of as like adding cloud to existing products. And then there is AI first products, which are rethinking the mental model from scratch. And I think the cloud analogy there is like Salesforce. Well, we're going to rethink the business model. We're going to rethink the delivery system. We're going to rethink the entire thing. And another one that comes to mind is, we went from client-side photo management to cloud photo management with Flickr. And then Instagram said, screw all that. The native mobile photo app is about filters and about streams. And they threw out the whole playbook, right? And so the question in my mind, and I imagine from YC's mind, is not, hey, everyone's using AI, everyone's sprinkling AI on everything. It's what is the AI first product and company that will be born in each of these categories that completely throws out the playbook and rethinks it from first principles. And I don't think there is enough people thinking about it that way. And we don't know what the answer is, right? We don't know what that looks like yet. Now, all of that past is prologue, all of that is history. The question that I continue to bring up, though, is in a world where the AI, the LLM, the general foundation model might be able to generate its own UX, then the world of creating fit for purpose products from separate vendors may be less relevant. May be less relevant. May not, but it may. And so that playbook of each new platform creates a new set of winners with a new mental model that may not play out this time, but we'll see. Maybe history just repeats or rhymes. The quality of execution piece, the quality of thinking it through from first principles, the quality of what a Brett Taylor does versus what a random other entrepreneur does, these all matter a lot if you're rethinking the business model, rethinking the mental model, rethinking the user experience, or they all get collided by ChatGPT and ChatGPT generates the UX and makes all the fit for purpose apps on the fly. We'll see.
I think the risk of what YC is doing with its sort of request for startups is, that's sort of like, we've got a hammer, let's find some nails to nail, right? So it's like, okay, we've got AI and let's find a problem to solve. And it can be a little bit like mechanical. But then we have the opposite problem, right? Because the ideal founder in this space now knows that AI is a tool that they can leverage, but they've fallen in love with the problem. Like we talk about that a lot on the podcast. So we have founders out there and they're like, I'm building in this space. And I've realized that I need to leverage the LLM technology that's out there. But just as I was saying with the cloud 7, 8, 9 years ago, they don't have the skills, the technical skills and the understanding of the space to be able to do it effectively. So what's your advice or recommendation to founders who find themselves in that situation? And there are many, many of them. What's the right move?
The founders that have already fell in love with the problem, or the founders that have the hammer and looking?
I was talking about the ones who already fell in love with the problem, because I think there are founders everywhere going, oh shit, I can't ignore AI, but I also don't know how to do it.
Yeah. First, let me just say, I completely agree with you about falling in love with the problem is like the most important thing. Like knowing a lot about AI, that's not going to get you anywhere. I mean, part of the reason we started our AI consulting is because if we had a problem that we fell in love, we would have done that. But short of that, because I wanted to work in this space, this seemed like the closest thing that would expose me to problems that I might or might not fall in love with. Now, if you do have a problem that you fell in love with, again, ChatGPT 4 helped me implement a multi-headed transformer from scratch. Like you really can learn these things that would have taken you like 3 months. You can kind of pick up to a point where you know the foundation, where now you know this is the skill set you need to hire. Now I'm going to go find the person that I need. This in a tremendous way will help founders just to build foundational knowledge about the area. So a lot of the founders, technical founders who are already in AI, they basically don't need help and they kind of know what they want to do. And as long as they understand the problem, they can hopefully make progress. Then you get to like founders who are not really AI savvy. Just think like a lot of startups in climate. They have to deal with lots of challenges around data, around pattern recognition. And most of these folks that are successful are hard science people. We've been talking with a lot of VCs, and one thing that they told us is that you guys can sort of consult with them and help them sort of get up to speed and build the muscle around this area. Basically, it starts with like, how do you have a culture of being data driven? How do you collect data? What do you use the data for? Like you have to do all sorts of these steps in order to basically have an AI strategy. On the other hand, the other set of folks that I think we can help with is basically non-AI, maybe non-tech, mid, small size companies that are already sitting on a lot of proprietary data, but they don't know what they can use it for. And as Chris said, like sometimes they need to rethink their business model. Sometimes they need to like actually utilize the data that they already have. And in a lot of cases, they can basically eke out efficiency and productivity so that their workforce can focus on what matters as opposed to like just like busy work. And I think these are the areas we're hoping to bring to the non-AI sector and help it as much as we can. That's really where we are right now.
I think sort of just reflecting on all of this, one thing I would say to founders, again, drawing on this analogy with the cloud last decade, is that there is a temporary increase, maybe not temporary, but there's an increase in the level of technical capability that is going to be required to build a great startup. I think the way technology has evolved, cloud and everything, and the sort of SaaS landscape for the last 10 years has been more in the direction of making it easier to build software, right? Requiring less technical depth to build most products, right? You've got all of these no code tools and SaaS and cloud deploy and everything. And it's like, okay, you still need technical folks on the team. You still need engineers usually, but it's become more commoditized. And I think what this has done, it has sort of reset things and decommoditized it a bit again and saying, technical depth is going to be important in most startups so that they can properly leverage AI in solving the problem that they've fallen in love with.
I'm not currently convinced, and that may be just because I'm not technical enough like you guys, that implementing AI is all that hard. There's big, heavy, hardcore foundational models, and some of that is being open source, and some of that is behind the point of an API. There is proprietary data, which is becoming easier and easier to just submit to a model for as the knowledge base or as a retraining or fine-tuning exercise. And then there's an endpoint, right? Like, here's some data, go do some inferencing. I don't know, and again, this may be some naivete on my part, I don't know where the heavy lift is here. For an everyday engineer implementing stuff for their application or even thinking about things from first principles, a lot of the heavy lifting has been done for you, and it's at the point of a very simple API call. So I'm not sure that the toolchain journey and the technical complexity journey is going to be the same with AI. Where do you see this kind of deep need for toolchain complexity commoditization? I'm not sure I see it.
I think two things. One is, I think what Yaniv says applies strongly to non-tech companies because I think they don't even know where to start, what to do, even in the use case that you just laid out, like, oh, just do this, do that. The second problem with it is even the tool chain that you just outlined, Chris, with like, okay, put the data here, there's the endpoint, make the custom GPT, blah, blah, blah. We know it's not there. Like we know it forgets, we know there's hallucination. So like there's still like basically a lot there to be done in order to have like sort of a trustworthy product.
Those feel like version 1 feature bugs, right? Like I'm already seeing just incredibly beautiful enterprise tools where you can like upload your corpus of data here or connect to your data blocks and connect your Snowflake instance over here, set your rules and parameters here, and like click play. This is low code, no code enterprise management on top of existing heavy duty stuff. And those foundation models will get better at recall, better at hallucination, better at whatever. If I'm a cloud climate science company or I'm a BHP bulletin, digging stuff out of the ground, I'm not going to go get my engineers to go start building AI infrastructure. That's not going to happen. Or I'm going to use the big 4, big 5. I'm going to use Hugging Face libraries, open source stuff, and, just smash it into my existing workflow and keep going. Am I not?
Yeah, I think now I see what you're saying, and maybe it applies actually directly to me. So I'm not an AI researcher. I did not develop architectures for foundational models. I was even skeptical about like getting into space would be worth it because the big 4 is just going to dominate. But what has happened, as you said, these things have become these building blocks that both available open source, closed source, and there's so many of them, so many variation, and it's moving so fast and improving so quickly that it convinced me as a builder. Now I have these building blocks, which I'm confident any other builder will feel the same way, that they can utilize and put together to solve problems. So on that sense, I agree with you. I think I see the space as like a huge Lego set that you can put the pieces together to solve the problem appropriately. And then you have to have that nice magical touch in terms of the product to sort of get the customer to stick, which is its own magic.
All right, guys. Well, that seems actually like a perfect place to wrap things up. Thanks so much for coming on, Ali, for this special Reacts to talk about all the changes in AI lately and all the developments. It's been great. So, as you mentioned, you have a business consulting in the AI space. So if people might be interested in finding out about what you do and potentially working with you, where would they find you?
People can find me on LinkedIn at Alireza Ali or on our website, theblue.earth.
We'll have that in the show notes. Yaniv, how can people find you?
Well, I'm mostly on LinkedIn, so you can find me there. Love a follow or a connection from TSP listeners. I also am on Twitter, and I mostly just sort of troll people there. So if you want to see that side of me, I'm at @ybernstein.
Awesome. And I'm at Chris Sard on all the social media and on chrissard.com. Feel free to subscribe to my newsletter there. And also, don't forget, if you've listened to just a few episodes of the Startup Podcast and gotten value, we ask you to please honor the Startup Podcast Pact, which says please rate us and review us and follow us in your favorite podcasting app and share us and tell the world about us on your favorite social network. It helps us grow the show and help founders like you.
Really means a lot.
All right, guys, great conversation as always.
Thank you for having me. Really appreciate it. It was fun.
It was fun. Thanks, Ali. It was great.
All right, see you later. Bye-bye.
Bye-bye.
This episode of the Startup Podcast was brought to you by Vanta. Vanta helps businesses get and stay compliant by automating up to 90% of the work for the most in-demand compliance frameworks. With over 200 integrations, you can easily monitor and secure the tools your business relies on. Head to vanta.com/TSP for 20% off their incredible offering and start unlocking extra revenue today.